And the test has now begun. Now this test is a 5-point test running from zero flow up to the maximum or full scale set point of the mass flow controller. Our 50 SCCM flow is particularly challenging for a lot of gas flow standards. The low flow tends to make it slower to reach stability and also makes it a little harder to get accurate data. This is a good way to highlight the advantage of getting continuous flow using the MOLBLOC and getting nice, fast, automated data using Compass software. Now, while the test is running, I'll describe for you some of the components that are being used. The MOLBOX-1 terminal is taking measurements from the MOLBLOC, both pressure and temperature measurements, calculating flow. This is one of a couple of MOLBOX terminals offered by Fluke. We have the MOLBOX RFM, which is a smaller, portable, lower cost MOLBOX terminal, and then this MOLBOX-1 which is a replacement or update for a very popular MOLBOX-1 terminal that has been on the market for some time. Now during the test, the MOLBOX-1 is going to measure both the upstream and downstream absolute pressure and also the absolute temperature coming through that cable off of the MOLBLOC to calculate flow. The MOLBLOC and the MFC are both sitting on a mounting platform called a MOL stick. The MOL stick, in addition to providing convenient connections and mounting for your MOLBLOC and device under test, also includes all of the components needed to provide a stable pressure and clean supply gas to come through. We have a filter on this MOL stick, a specialized pressure regulator used for low flow, and a shutoff valve. And in cases where it's needed, a gas flow control valve can also be included on the MOL stick. Now our MOLBLOC here is a laminar flow element type MOLBLOC, or MOLBLOC-L. Our laminar flow elements in the MOLBLOC system are unique in that they use a patented design that includes a thin flow path for the gas to travel through the MOLBLOC, which is defined in this case by a piston and cylinder. So you have a very small annular space that produces up to a 50 kPa or almost 7 psi pressure drop, which is much larger than typical. And it also allows us to measure the temperature accurately by forcing the gas to take on the temperature of this relatively large MOLBLOC body made of stainless steel, which acts as a heat sink. The temperature is measured then by platinum resistance thermometers embedded into the body of the MOLBLOC. And both the temperature signals are collected and passed on with this electronic board on the MOLBLOC, and also the calibration coefficients are stored on an EEPROM on the electronic board as well. Now returning over to our test, you can see that both the reference indication, which is coming from the MOLBLOC and MOLBOX measurement, and the device under test measurement are shown. You have error calculations shown in both percent of reading and percent full scale. And note that we have both an error and a set error indicated on the screen. With mass flow controller calculations, some customers would like to see an error related to the output of the device under test relative to the measurement output of the reference. And in some cases, you'd prefer to see how well the item sets flow with respect to the set point signal that was sent to it, and that would be the set error. In our case, we're using the error, and that's what's being both recorded here and shown in the plot in the lower right-hand corner. On this plot, you can see error bands of plus and minus 1% full scale indicated by the dashed green lines. Now, this MFC, both on the third and fourth point, you can see we're out of tolerance, and so it's going to need adjustment to bring it back into tolerance before returning to the field. We have one more data point, which is now being collected. At the moment, we're waiting for flow stability, which is indicated on the progress bar at the bottom of your screen. Note on the lower left in your data grid, you have just some of the data that's being collected by Compass. There's a lot more points being collected here that can be used in the data report later, but it does show the output of both the device under test and the reference MOLBLOC on each point. Indicates whether flow was stable and shows both the percent of reading and percent full scale error. Right now we have a good looking data point at 50 SCCM, or 100% of the range of the MFC. And there's our final point recorded, which shows intolerance at the top and bottom, but a pretty poor linearity and some need for adjustment, particularly in the middle of the range. Now the test will pause, ask us for notes, and it is finished, and we can move on to adjustment of the MFC.